I'm going to describe some steps to develop an HMM-based isolated word speech recognition system. We are going to go through 3 steps. First, organizing the files in directories, and then we are going to train the HMM system using Spock, and after that we are going to use Dukov to perform online speech recognition system. I'm going to assume that we want to design a system to recognize 4 words: left, right, up and down, and we are going to use Audacity to record wave files. So basically, if you open Audacity, you are going to get an interface like that, and then you have to choose the sample rate. Here you already have 8000 Hertz, but if it's not your default, you can go to the edit menu, preference, or Ctrl P, and then you get the number of channels. We are going to choose mono. You are going to choose also, here, the quality, means the sampling rate, and also we are going to choose 16 bits per sample. There are other options, of course. And then after you have that, you can record left and export as a wavy file. So I'm going to use a directory tree where each directory is corresponded to the word. For example, we are going to have 4 directories. I'm going to show you, for example, down, left, right, and up. So I'm going to put here left, my first left one, for example, and then I'm going to close this, record another one, left. So here there is some sounds that I don't want. Ctrl K to delete, and then I'm going to export, and this is my second wave file. So I have to do that as many times as I can. The more data, the better. And after having recording, let's say, 10 occurrences of left, we can then go to choose another word, right. Again, this one is not the words I want. There is lots of silence here. I can also cut it, and then save my first occurrence, or my first wave file corresponding to the words right. So I'm going to say it's right 1.wave. So after that, I should finish with 2 directories: train with all the wavy files for each one. I can also have a subdirectory. For example, let's say you have a speaker, my name, for example, James, and then another speaker, John, and so on. You can place the wavy files inside the directories. The important thing is that the root directory has only the number of directories that your speech recognition system has to recognize. In our case, the 4 words: down, left, and then right and up. Because I don't want to record much data, I'm going to use a data set that's part of the TI digits data set without sampled to 8 kilohertz, and so we called it TI digits 8 kilohertz, and has only 1 word per file. So I have the train and the test directory, and both have all the digits from 0 to 0 up to 9. Where is 9? Here. So if I go inside, for example, I can see that there is a directory man, woman, and then lots of wave files. In fact, 55 wave files for the word 8 spoken by man, and also in this case 57 items corresponding to 8 by women. And then if you go to tests, they have another set of wave files also organized this way. So basically, now that I have all my wave files organized in this kind of directory tree, where it starts dividing training and tests, and inside train you have the number of words that you want to recognize, one words per directory. Now I can go to the second step and use this do-cov to train the HMM-based system. So I'm going to use two softwares. Where is it? Here. I'm going to use two softwares. One, they are both here. One is Spock, that's inside this jar file. So I'm going to open this command line, and you can see this jar file. So if you go like Java speech, then you open this do-cov interface. Basically, you have to specify the front end and the HMM that you want to use for each word, and we are going to start from the front end. So I'm going to provide a configuration file. I could choose one opening it, but if I don't have, I can press here, edit, and it's going to use a default configuration file that has many parameters. So you can see sampling rate 8 kilohertz, and I'm going to save the original. I'm going to put it here. I'm going to save it here. I'm going to call it FCN. That's the standard extension to front end. Stands for front end configuration, FCN. So I'm going to save it, close, and now I have it here. I'm going to choose the waveform directory. So this has to go to my it's better to browse this guy, PI digits. So the training, I have to choose the training directory. So just to remind you, where it has all the subdirectories that I need. So now everything is set with the front end. I'm going to choose the HMM model. So this option here would be used if I already had used the front end, or already had the front end parameters. Because I don't, so I'm not gonna use this thing. I'm going to choose MFCCs, and this is all the information that I need. Now I'm going to do the same. Because I don't have an HMM configuration file, I'm going to click here to open it, and here it's important to describe the number of features, because from my front end file, let me show you. If I look at it, the number of parameters, if you go down here, you are going to see the number of parameters at some place. Okay, this is the number of base parameters, 12, but then I'm including energy, so it goes to 13. The first derivative means 26 parameters, and then the second 39. So I know that I should put here 39, and this is the number of states. I can use, for example, 7 states per HMM, and I can save it as HMM HCN is the default extension for an HMM configuration file. And now I have to provide the test data. So the test data is going to use this waveform directory, that instead of the train, I'm going to provide the test waveform directory. So here I go with the test. And now I can provide the outputs directory, this guy here. So I'm going to say it's called outputs and choose. When I make all the options valid, this guy goes green, meaning that I can start the simulation, and it's just a matter of pressing start, and it's going to run the front end first and then train the HMMs. And you can see the slider bar indicating the status, and also you can look here. For example, it wrote the transcriptions and wrote to this directory outputs transcriptions, both for the test and the train sets. Now it started running the front end, and